Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of dilation representations. This is standard 8.3c in the great state of Texas, and we are using item number 24 off the 2019 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a polygon graphed on a coordinate grid with x, y representing the location of a certain point on the polygon. So we're going to transform it using this rule. xy gets translated into ax and ay. So they're not even going to tell us what type of transformation it's going to be. Could be a dilation, could be a translation, rotation, or reflection. So we need to find one true statement. Well, we could use our logic, but I always find it a little bit easier to draw a sample, and let's just see what happens. So polygon, let's just go with a super basic polygon. Let's just make it a triangle, okay? So we're just going to kind of do this right here. Let's just keep it right there on the x axis, right? So let's just call this 2, 0. Let's call that -2, 0, and let's call that 2, 0. All right, or 0, 2. Let's make it equilateral. It might not look equilateral, but let's just pretend it's equilateral. All right, so what can we do here? We're going to transform each of these points using ax, ay. All right, so a we're going to multiply by the x and y, and they've got options here of greater than 1. That is there twice, and then between 0 and 1. All right, so let's see what happens if it's greater than 1. Let's just make a equal 2, right? So what I'm going to do here is I'm going to take my xy, right? Let me take this 0, 2, and I'm going to transform it because I'm going to multiply each of those xy coordinates by 2. Right? So 2 times 0 is still 0. 2 times 2 is 4. All right, so that becomes 4. Let's double that up there, 0, 4. This will end up becoming 4, 0. That's why I picked everything on the axis, a lot easier. And then this is going to end up being -4, 0. Wow, so look at that triangle. It goes all the way up there. All right, so that's what happens if a equals 2. Now, if a is between 0 and 1, all right, so let's see what happens if a equals, let's just call it a half. All right, so still take that same point, 0, 2, and we'll see what happens, use that as a rule. All right, so it's going to be 1/2 times 0, still 0. Oh, and let's make that 1/2 times 2. That's going to be 0, and then that is going to be 1. All right, so it's getting smaller. So it's going to be little guys like this. So that's my smaller one. So this is a equals 2, and this is a equals 1/2. All right, now we've got some pictures, and we can actually look and see what we're going to be doing on our options here. So let's see on F. Put those points there. If a is greater than 1, that's this bigger one right here, the image of the polygon is congruent. No. It got bigger. If a is between 0 and 1, that's the smaller one right here, the image of the polygon, no, it's not congruent. You know what we did? We dilated it. We made it larger or smaller because a is a scale factor. And when you scale factor, you're going to multiply it by something to make it bigger or smaller. So if a is greater than 1, that's this one, the image of the polygon is smaller. Nope, it got larger. If a is between 0 and 1, that's this one right here, the image of the polygon is smaller. Thank you. It's the last one. That's why drawing pictures is usually helpful. It's not congruent. It is smaller, so our answer here is going to be J.